Hello and welcome to this Easy Composites video tutorial on how to make carbon fibre sheet. So the aim of this tutorial is to show you the ease with which you can make a commercial quality carbon fibre sheet, either sort of thin sheets for cosmetic applications or very strong sheets for structural applications. And we'll be looking at three different manufacturing techniques that can be used to make those sheets. So hopefully at the end of the tutorial you'll have an idea of the right process to use and also the right material selections that will help you to achieve a sheet of the exact specification that you require for your job.
The three different manufacturing methods we'll be looking at today to make our sheets are a simple hand layout process using dry carbon fibre fabric hand laminated using epoxy resin infusion, where we'll be using a vacuum process to infuse epoxy resin through a dry carbon fibre reinforcement, and finally oven cured prepreg, where we'll use uncured prepreg carbon fibre, vacuum bagged and cured under vacuum in an oven. But before we start looking at these processes in detail, there are some important factors that are common to all of these processes.
So first things first, when making your own carbon fibre sheet is the thickness of the sheet. So we're going to assume that you know the thickness that you're trying to achieve and that we're trying to work out how many layers of reinforcement we need to achieve that thickness, because essentially that is how we determine the thickness of a carbon fibre sheet, is the weight and the number of plies that we've got. So taking a look at some reinforcements here, if we take these vernier calipers on this 650 gram carbon with a sort of light contact pressure, we're getting a thickness of around about 0.7, 0.75. If we just put some pressure on the vernier calipers to simulate the consolidation that we'd get from a vacuum bag, then you can see we're around about 0.65, which is about the thickness that this material would be in a vacuum bagged laminate. So generally, as you can see, the thickness is dictated by the weight, but different types of reinforcement, such as this multi-axial that we've got here, will consolidate differently. So if you were to get the verniers on this, you will find a bit less consolidation, a bit less sort of springiness in a multi-axial or a unidirectional. And another quite interesting thing that you'll find with wovens particularly is that their weight in grams does tend to correspond pretty closely, certainly in a vacuum bagged laminate, to the thickness. So if you've got a 650 gram carbon, it will tend to result in a thickness of about 0.65 millimeters in the laminate. So 200 gram, around about 0.2 millimeters in the laminate. Because different formats like UDs and multi-axials and different fibre types, so carbon or Kevlar, all consolidate differently, on the Easy Composites website we do list a consolidated thickness as well as a nominal thickness for all of the reinforcements that we stock. One major advantage to making your own carbon fibre sheet is that you can tailor the performance of the sheet by varying and controlling the fibre orientation to ensure that you've got the maximum strength in the direction and the axis that you actually need that strength. So this is an example that we use on our training course. So we've got these two test pieces or samples that have been cut from exactly the same carbon fibre sheet. This one's been cut at this angle and this one's been cut at 45 degrees, so you can see the weave pattern matching the sheet that it was cut from. So if we take this section that was cut at 45 degrees, can really bend this sheet very, very easily. If we try and twist it torsionally, crikey, very, very strong in that direction. So if we then take the other piece that's been cut at 90 degrees, so straight across the sheet, in that direction, very, very stiff. But if we try and twist it, its torsional strength is far, far less than this one cut at 45 degrees. To take advantage of the way that fibre orientation can determine the properties of the sheet, we'll use a range of different reinforcements, such as unidirectional. We'll use a bias cut woven cloth and also a biaxial in our sheets, and we'll start that with the wet lay.
You'll find that glass makes by far the best surface for creating your own carbon fibre sheets, but it will need to be prepared with a suitable release agent, generally a chemical release agent, and here we're using several applications of Easy Release. Next, we want to work out how much resin we need for our hand layups. So we're doing two different layups. The first one is going to be using solely unidirectional material, and that weighs about 28 grams here. And then we'll weigh the second stack, which is a woven cloth and a biaxial, and we've got a weight for that, total weight of 68 grams. So in both cases we want to mix up the same weight of resin as we've got in reinforcement. That's because typically a hand layup will be about 50-50 fibre to resin ratio. So we're using EL2, which is our epoxy laminating resin, and because these are only small samples, we're using the fast hardener. We start by brushing the resin directly onto the sheet of glass. Don't worry about this sort of fisheye that you see where the repellent slippy surface of the release agent repels the resin away. We weren't trying to create a consistent gel coat surface. Instead, what we want to do is make sure that we start off with the resin on the surface side, and that will work its way back into the reinforcement, and that just helps to eliminate air entrapment and voids on the surface. So always start with your resin on the surface and then put your first layer of reinforcement onto that. So then we can use a combination of brushes and squeegees to really try to wet out the fibre as best as possible, and we can turn the glass sheet over and have a look at it from the underside. You can see a couple of areas here where we've still got areas of reinforcement that aren't wetted out. So we'll proceed, keep checking, and we can keep turning that plate over, then building up the layers, each time wetting it out with more resin. But the trick to wet lay really is to reduce the amount of resin that you naturally want to use. You're not looking to thoroughly soak the reinforcement, just enough resin to wet it out, and that's really, really important. Otherwise you'll end up with a laminate that's much heavier than it should be. So we're using a squeegee again, checking the underside, and there we have our first sheet laid up. What we're going to do now is just apply a layer of peel ply onto the back, and this is really helpful, particularly with the wet lay, because what you'll see is that the peel ply can be used to absorb some of the excess resin that you'll inevitably have in your laminate. So you can see it wetting out the peel ply, and it also has the benefit of, when we pull this off, of leaving a smooth, consistent, bondable finish on the laminate. So we're moving on now to our next wet lay sheet. If we remember back to earlier on in the tutorial, we'd weighed this second stack of reinforcement at 68 grams. We do actually mix up a little more than that, I should have mentioned earlier, because you will inevitably have some resin that remains in the pot and on the brush, and that needs to be allowed for. So I think in this case we mixed up a total of about 80 grams. Being another wet lay sheet example, we are following the same process. We've started by adding the resin first to the surface, and then our layer of 200 gram 2,2 twill carbon has gone down first. The first layer with any carbon fibre sheet is always going to be cosmetically the critical one, so we're having a look again on the underside, checking for any dry patches. You can see we've got some dry areas here, there's some other at the top. So what we're going to do here is just make this first layer a bit resin rich. We'd normally try and avoid excess resin in a laminate, but we'll add excess resin at this point so that we can ensure we've got that surface layer fully wetted out, because that's very critical. That's the layer you'll see. So we're now adding our second layer of reinforcement. This is a biaxial, so it has its fibre oriented at plus and minus 45 degrees. And the reason we're using this reinforcement is to create a more even consistency, or a more even distribution of the strength in this sheet. So rather than using exclusively the 0-90 woven fabric, we've got these alternating layers of plus minus 45. Now we're adding another layer of 0-90 woven, another layer of plus minus 45, and then finishing the final layer of the woven cloth before adding the peel ply, just as we did for the previous sheet sample. Again, we'll use this to absorb any excess resin in the laminate and give us that bondable, consistent finish on the reverse.
So that's our hand layup sheets completed now. We're just going to set these aside and let them cure at room temperature. And so now we can move on to our next practical demonstration, which is the resin infusion. So we're going to do two different layups again, two different examples. The first example is an exact match for one of the wet lay sheets that we made. So we've got the layers of 200 gram woven cloth and the biaxial. And then the second demonstration will be a much thicker laminate. We've got 6 layers of 650 gram carbon here to show how resin infusion can be a very effective way of making a strong structural sheet.
We're using a medium-sized sheet of glass for the resin infusion demonstration, but do remember throughout this tutorial that a process particularly like resin infusion could be used to make a very large sheet indeed.
Okay, so this will be the simplest layup you'll probably ever see us do. We've got our 2 layers of reinforcement, or 2 stacks. Firstly, the thick 650 gram, and second, the replica stack from the wet lay that we did.
In this tutorial, we're going to move quite quickly through the resin infusion setup because we have covered this in detail in various other tutorials that we've done. But we are going to identify a couple of points. The first, you can see where the laminate ends here on this sheet. Now what we want to do is set up a resin break. So the infusion mesh is going to facilitate the flow of the resin through the laminate, but we've got this area at the top where we have peel ply with no infusion mesh, and we're calling that a resin break. And the idea of that is just to slow down or practically halt the flow of the resin through the laminate when it reaches the area of peel ply where there's no mesh, and that gives us plenty of opportunity for far corners of the sheet to get fully infused before the resin starts being drawn down the vacuum line. And of course, as ever, it's essential to make sure that this bag is really well and truly sealed.
The last stage of our very simple resin infusion setup is to just puncture the bag here and here for our resin feed and vacuum lines and connect them up to the vacuum pump and catch pot.
You'll notice here the sloped cut that we've got on the PVC hose. That does help a lot in terms of getting that hose into the resin infusion connector. Now you'll notice with an infusion like a sheet, you've got very little air in the bag, so when we do switch the vacuum on, the bag will pull down very, very quickly and be at full vacuum within just a few seconds. What we've done is we've included a leak flow indicator in our circuit, and that's just quite helpful. We can keep an eye on that. It sits between the pump and the catch pot, and when that stops spinning, we know that we've got a pretty much perfect sealed bag. So we're using our Easy Composites IN2 infusion resin, which is a special low viscosity epoxy infusion resin, and that will ensure that this infuses through the laminate reasonably quickly. We've positioned the connector in the middle, and we've got the spiral in a U shape, which is quite common setup for a sheet like this. And you can see where you've got the spiral at the edges, that's creating this sort of U shape. And what we want that to do is reach the vacuum line on the other side last. And you can see at the top here just how effective that resin break that we set up is. Where the resin's gone over the mesh, it's advancing quite quickly, but as soon as it reaches this peel ply only area, the progress of the resin pretty much stops dead.
Okay, so that's it. Simplest infusion ever. So again, like the wet lay sheets, we'll just leave this now to cure at ambient temperature.
This leads us on now to the final technique that we're demonstrating in this tutorial, which is a prepreg carbon fibre layup. And I'll start this by marking out 2 layers that we're going to cut on the 45-degree bias, and then we'll mark up a final layer that we'll just cut at the normal orientation. And this will allow us to alternate these backing layers inside the sheet and produce a sheet that's got a fairly uniform distribution of strength.
And then we'll finish our laminate top and bottom with a layer of the 240 gram Easy Preg. So this is the out-of-autoclave surfacing prepreg that's going to be necessary, certainly on the A side of the sheet, to give us that pinhole free surface finish.
We couldn't really have a simpler layup than when making a carbon fibre sheet. It's simply a case of layering each of these plies of reinforcement. So we started with the surfacing prepreg with its resin film side down. Now we're applying each layer of the 430 gram backing, which we've got with the alternating fibre orientation. We're using a consolidating roller here just to help to consolidate the reinforcement. And then we can move on with our final layer, which is a mirror of the surface. So we're using again another layer of the Easy Preg surfacing. Now it doesn't need to be a surfacing ply on the back because we're not looking for that pinhole free surface finish on the reverse. However, it is considered best practice to balance the laminate wherever possible, and so that's what we've done in this case. With the layup complete, you can see that I'm now preparing the vacuum bagging materials. Now we're going to position our through bag connector into this area here. So when I'm setting this up and positioning it inside the bag, I've got my breather with a nice space to one side, and that's going to allow me to position the through bag connector. What I can show you that's new here is that on this connector we're using one of our quick release couplings. Now if you're doing a lot of vacuum bagging, particularly with prepregs where you've got potentially multiple bags and you're transferring them from your laminating table into the oven, then these connectors can be really helpful. Here we are just peeking the bag in the usual way and snipping it through to make our hole, and that'll just allow us to open that up over the connector on the inside, put the other side of the connector on the outside, pinch it up, and then we can just make use of that quick release coupling which is self-sealing, so just push it on and it will instantly open up, connects up the vacuum, and again it only takes just a few seconds for this bag to pull down completely.
So that's our prepreg layup concluded now, so just a case of loading this into the oven to cure with the vacuum still applied.
If you'd like to know more about the cure temperatures and times and general cure cycles for our prepregs, then please take a look at our website where we've got full details on these.
So that's our complete set of cured samples now. So we'll take these bagging consumables off and have a look at the sheets that we've made.
It makes sense to begin with the wet lay sheets that we made at the beginning of the tutorial. Peel ply comes off easy enough, and as you can see, very straightforward to remove these from the glass. We never ever expect to have any problems releasing a carbon fibre sheet from a glass surface prepared with Easy Release. These are our resin infused samples. Those are very sturdy, one produced from multiple layers of the 650 gram, and then just a case of taking out the prepreg sheet as well, removing the bagging consumables and just teasing this one away. The slight hesitation here is just caused by the resin that's run around the edge of the sheet on this one.
I'm going to trim these sheets now so they're all the same size and we can make a proper comparison. If you'd like more information about cutting and shaping carbon fibre, then we've got a video tutorial on that subject that'll give you all the information you need. The first thing we'll do is have a look at how the number of layers affected the finished thickness of these sheets. From the start of the tutorial, the first sheet that we made was the unidirectional, which we did as a wet lay process. And if we have a look at the thickness of that, we've got around about 0.9 millimeters on that one. We did another wet lay sheet where we had 3 layers of 200 gram and 2 layers of 300 gram, which means that we were anticipating a thickness or a consolidated thickness of around about 1.2 millimeters. If we have a look on the verniers, we've got a little bit more than that. This has come up at 1.8 millimeters. And the reason, of course, for that is that this is wet lay, so it didn't have the vacuum consolidation. We did the exact same layup with the resin infusion, and if we have a look at the thickness of that, then that's much closer to the thickness that we were anticipating. So this is coming up at 1.3, and we were expecting around about 1.2. So that's pretty close to the consolidated thickness that we'd expected. We did a second infusion, this very, very strong, sturdy 650 gram. Now this is coming up at around about 4.1, and we were anticipating around about 3.9. So again, very close to the consolidated thickness that we'd expected. And finally, we did the prepreg sheet. Have a look at the thickness of that, around about 2.2 millimeters on that one. Another thing we looked at when we made these sheets was fibre orientation. Probably the most pronounced impact of fibre orientation was the unidirectional sheet. So in this direction, extremely flexible. In fact, I could certainly flex this and snap it in that direction. But in the direction where we have the strength, where all of the fibres are running lengthways down it, then extremely strong, certainly for its thickness, in that direction. In the second wet lay sheet, we tried to create pretty much the opposite of the unidirectional, which was to create a sheet where we'd got an even distribution of the strength, so across its width and its length, and then also on the 45-degree axis. So torsionally resulted in a very even balance of the strength on this sheet. Then we move on to the resin infused versions. So same sheet, same specification, and again, we've achieved the exact same even distribution of strength. Now we're not really going to be able to flex this heavy 4mm sheet. In fact, I simply cannot flex that in any way whatsoever, but it does show how you can make a very strong structural sheet using resin infusion very easily. And finally, the prepreg sheet. Again, we did multi-axial orientation of the fibres, so we had the 0-90 and ±45, which is giving us that same even distribution of strength. So that's the physical properties of these sheets looked at, but what about the cosmetic finish? Because that can sometimes be very important too.
We won't pay too much attention to the unidirectional sheet because that's highly unlikely to be a cosmetic sheet, but we can certainly take a look at these comparison between the wet lay sheet and the resin infused sheet. Both of them have got exactly the same surface ply, but the resin infused sheet has an absolutely perfect surface finish, whereas on the wet lay sheet it's pretty much unavoidable that you will get these tiny pinholes on the surface. Finally then, we've got our prepreg sheet. Not the easiest thing to show on camera, but as we've come to expect before from this material, we've got a fantastic cosmetic grade surface finish on this as well.
In conclusion then, I hope you've seen how easy it can be to produce your own carbon fibre sheet. There's just so many things that you could use this for, too many to mention. If you're interested in the processes that we've covered in this video, whether it's the prepreg or the resin infusion or even the hand layup, then take a look at our YouTube channel. We've got lots more videos that cover these topics in more detail. So please stay in touch with us, subscribe to the YouTube videos, and we'll see you soon.